Okay, so here we go. We're talking about some special situations like in number 9 and in number 10. So number 9, our point is 0, 5. So that would lie on the y-axis up here. All right? So we know our x is 0. We know our y is 5. Now, if we think about this in terms of the circle, if we think of this as in terms of a rotation, this would be a 90 degree. But if we think of this in terms of the circle that would form, whoa, wrong. Hold on. Undo. Start right here. There. Okay? We would see that in this particular case, the y is the same as the radius. Do you see that now?
Yeah.
Now that we drew the circle, and if we think about this in terms of an angle of rotation and rotating all the way around, what are all of our possibilities? Well, this y value is the radius. Okay? So, when we come down here to what we learned yesterday about our ratios, what we could think about them on the coordinate plane, sine is the y over the radius. So in this case, it would be 5 over 5, which is 1. Cosine is the x value over the radius. So it would be 0 over 5, which is 0. Tangent is the y over the x. But what did we say yesterday? X cannot equal 0 because in that case it would be undefined. So tangent is undefined when the terminal side passes through the point 0, 5. Guys, what would the angle of rotation be for this particular point? 90 degrees. So tangent of 90 degrees is undefined.
What about 180?
No, we'll look at that in a second. All right. Cosecant, yes. Yes. Tangent of 270 would also be undefined because what is the x value there? 0. All right. Cosecant. So we would do the reciprocal. Well, the reciprocal of 1 is 1. But here when we do the reciprocal, we get 5 over 0. So in this case, secant is also undefined. But tangent was undefined, and its reciprocal is actually 0. Because when I do the reciprocal of 5 over 0, I get 0 over 5, which is 0. Okay? So, does that make sense for number 9?
Yeah.
All right. Well, number 10 works the same way. Okay? So, let's take a look at number 10 now. Number 10 is the point -3, 0. So, if it works in a similar fashion, sine would be 0 over, what's the radius?
3.
3, so it'd be 0. Cosine would be -3 over 3, which is -1. Tangent would be 0 over -3, which is 0. Cosecant would be the reciprocal of this, so it is now 3 over 0, which is undefined. This one would stay -1.
Yeah.
Because when I do the reciprocal of -1, it's still -1. And then this one, we become -3 over 0, so it would be undefined. So the pink is number 10, the black is number 9. And so those are the special things that can happen. Because in those cases, it doesn't form a triangle. So if it's on the y-axis, the y is your radius. The length of y is your radius. But your radius is always positive, right? And if it's on the x-axis, the distance from the center to the x is your x. All right. Now, 17 and 18. We had to think about which quadrant that terminal side would lie in. So 143, kind of drew it. It's lying in that second quadrant. Now, yesterday we talked about would sine, cosine, and tangent be positive or negative in the different quadrants? And we tied it back to the values of x and y because we said r is always positive. So, in this case, in 143, we put it in this quadrant. The x is negative, so cosine is negative. 192, that'd be slightly past 180, right? So this would be in the third quadrant. What is tangent in the third quadrant? Positive. Did that help clear up any confusion with the homework?
It did.
Okay. Any other questions about the homework before we move on? Yes, sir. Sure. It'll be in today's notes also. Yes, sir.
Why do we need to know the tangent of 192, like in any situation?
We don't yet.
Yes.
What you're asking is, how would we use this to solve real-world application problems? And we wouldn't use the 192, we would use the reference angle. And we're going to talk about those today. Yes, sir.
I'm confused. So is the top right quadrant 3? I thought that was quadrant 1.
1, 2, 3,
Just wrote it there.
and
Oh, okay.
4.
I thought when you wrote it there, it meant
Because
so,
it's next
yeah.
to the tan 190.
No, this was the answer to number 18. That was the answer to number 17. Sorry about that. Okay, so Edward, if what I just talked about made sense, then you're probably fine for what we did yesterday.
Okay, like half makes sense.
Okay, well maybe today it'll completely make sense. Okay, so here's today's plan. We're doing things a little backwards. Okay, we're gonna go ahead and have the lesson. And then I'm gonna give you some time to work. We're gonna watch the announcements, and you should be getting your test back. I had a working lunch, but I still didn't finish. So that's why I'm buying a little time at the end with you watching announcements and getting started on your assignment. I'm really close. So,
How are the grades looking?
If we don't get it.
well, I took notes of those people that started their warm-ups versus those that did not, and those that did what I asked will definitely get theirs back. Those that did not do what I asked, I'm moving their test to the end.
Oh, okay.
So,
Seems fair.
okay.
Wait, how many of these
So
All right.
it wasn't like a grade.
secants and then...
No, it wasn't a grade.
Wait, Miss Willoughby?
I have graded this much of the second page. So, you can tell I'm pretty close. All right, here's today's notes.
Is this for us to keep? I didn't even know. I just started writing things down.
Well, you didn't like that formula we did.
Oh my god.
You wanted it to be slant height,
I'll try to write my last
which is what it should have been. But that would have made it so much uglier, and it wouldn't have accounted for the overlap.
Oh, I know, no, just like, it's not that, it's just when I plugged in the formula, just nothing was.
Does that make sense?
Yeah,
Just told me
no.
at the beginning, you're like, just use the formula we gave you.
I did.
I said, okay.
I did. Because when I looked at that, I told Mr. Campbell, I said, my students won't like this because they will want
Still pet.
there to be an L in there for slant height, because someone will know that to find the surface area of a cone, you need the slant height.
It was just,
And,
squaring it.
and then we talked about it, we did a little math, we talked about the overlap, and we said, all right, here's what they're using. Because slant height would be even harder.
No, it's just when I got it, I put the calculator, I'm like, I don't know.
Okay.
How to do this.
All right.
Honestly,
Okay, I'm back. And so the beginning of this kind of sums up what we talked about yesterday. So when we have angles of rotation, we have the initial side. Where's the initial side located?
on the X
On the x-axis in that first quadrant. Then we have the angles of rotation. So where we rotate to that final side is called the terminal. That makes sense because what does terminal mean? End. Yes. All right. So in standard position, they're always the vertex of that angle will always be located at the origin. And we talked about yesterday positive angles or counterclockwise angles versus negative angles, or clockwise. All right. So do you see here that this terminal side has a counterclockwise angle of 130 degrees. But it has a clockwise angle of negative 230. But doesn't that represent the exact same terminal side?
Yeah.
It's the same angle of rotation. But its terminal side is in the exact same place. So These two angles are called coterminal because that terminal side is located in the same place. Now, we got there two different ways, didn't we?
Yes.
One we went one way, the other we went the other. But in terms of trig, where we end up is kind of important. Okay? So today we're going to look at coterminal angles. Wow! And we're done. All right. So this is where we should have been. So if this is the given angle, this is a positive 48-degree angle. Can we find the negative angle? Yes, we can. All right, so the negative angle would obviously go in the opposite direction. It would go this way. Okay, very good. So we would do 360 minus 48, which gives us 312, right? But it is actually a negative 312 because we're going in a clockwise direction. So our first negative coterminal angle would be negative 312. Now, it also asked for two positive angles. So yesterday, I went a little nuts at one point, and remember when I went loop-de-loo? Oops, hold on, I went the wrong direction. So this is my angle, but could I have ended up in the same spot if I went all the way around and back to there?
Oh, so
Yes.
360 plus.
Exactly. That is exactly what we would do. We would take this 48 and we would add 360 to it because the terminal side ends up in the same spot. So an equivalent coterminal angle would be 408 degrees.
Wait, can you
So-
say that and do the little swirly thing again?
Sure, sure.
Please,
All right,
thank you.
so currently, right now, this angle represents from right here to right here. And I'm there, 48 degrees. But I could have started right here, gone all the way around, and then back to here. So the all the way around part is 360. So what that angle, see how this one is just from here to here? So the second one I did went all the way around and back to there.
That's
Okay? So a positive angle would be 408. What would be another positive angle?
748.
768. Just add another 360. So all we have to do is add and subtract 360.
So, could you like theoretically do this for like infinity?
You could. Yes, you could. That's why I didn't ask for all of them. I specifically asked for two positive and one negative. Because you're right.
The
You
other way
could.
too, where you do like 2 negative.
You could. I could ask for two negative. All right. Okay, so you try B and C. I want two positive coterminal angles and one negative coterminal angle.
I don't know why I tried it. Right, negative 211. So what's
Is
the
it in the line?
I don't know.
360? I can't do that in my head.
second grade subtraction.
I'm good.
I got 149, 509, and negative 531.
Alright, let's go.
Let's add 360 that back.
And then I got negative 571.
Everything else.
Subtracted that 360.
She's gonna be back tomorrow.
Oh, you're just
No. Like, we're not doing listen activity or whatever on Friday. It's just like, there's just this artist, and I really want you guys to know about him. So we're gonna move back to test.
This is how
And
we
what? Okay. I don't know why we keep going to artists. They're supposed to be like good points. The only important artist ever was Botero. No, Botero. That Jesus. No, it was his interpretation.
Alright, did anybody get the third one?
7,200.
Yeah, but I like what?
Alright, Carson,
Yes.
share with me your answers to B.
Let's see.
No, just read them off your papers.
149, 509, and negative 571, or 7,489 to the power of E. No, I'm just kidding.
So what was your negative one?
571.
My negative one was negative.
Okay, so those are acceptable. Those are the smallest angles of rotation that would be equivalent. Okay? Alright, C. Who would like to share with me?
No, I think about it.
Oh,
I think about it.
Alright, Jonathan?
Alright, so the first one is 226.
226.
Yeah.
Alright,
Then 586.
586. Good.
And negative 494.
Negative 494.
Oh, yeah.
Excellent. Okay? So does that make sense?
Yes.
Okay. So, now on the back, it talks about reference angles. Okay? And that's really what we're looking at. When we do those angles of rotation, it is critical that we can find the reference angle. Now the reference angle is the angle between the x-axis and the terminal side. Okay? So it's the reference angle is always going to be between 0 and 90 degrees.
Basically inside.
Okay? So this reference angle in the first quadrant would go down to here. Second quadrant here, third quadrant there, fourth quadrant there. And we talked about yesterday how those all form nice little right triangles when we need them to. Okay? So, this asks us to sketch each angle on an XY plane and determine the reference angle for each of the following positive. Alright, so how would this go? What we would do is we would sketch our XY. We would think about, once again, that this is 0, this is 90, this is 180, this is 270, this would be 360, we could keep going, okay? We want to go 300 degrees. So this would be 180, 300 would be about halfway. All right, 300 degrees, and there's my terminal side. So where would my reference angle be? It would be between the terminal side and the closest x-axis, which would be here. And what would that reference angle be? If this is 300, this would be 60 degrees.
Oh, I said 30. Is that right?
30 is not right. I kind of drew it more like it was 30. My drawing was a little off. There we go.
No, I mean, it wouldn't. Oh, it has to be to the x-axis.
Yes. Okay? All right. So now let's do this one here, F. Now this is in a negative direction. So this is still 0, but negative would be this way. Negative 90, negative 180, negative 270. All right, so this is negative 635. So all the way around would be negative 360, right? And then how much further do I need to go? So what is 635 minus 360 is 275. So we have to think about where that would be. So we have to go another negative 275. So that's negative 180, that's negative 270, whoop, just passed. Negative 275. So we're 5 degrees past vertical. Does that make sense? All right. So this would be our terminal side right here. This would be our terminal side.
That'd be 85.
Okay. And so our reference angle would be 85 degrees.
Positive or negative? Positive.
A reference angle is always positive.
It's always to the x-axis.
It is always to the x-axis. That is true.
Shut up.
All right. So now you try the ones we didn't do. All of
The
them.
negative just means clockwise, counterclockwise?
Yes, the negative means clockwise. Positive is counterclockwise.
I just think I need to realize that it's like not.
This one's 70 degrees? 60 degrees.
All right, so B was 45 degrees. C was 30 degrees. D was also 30 degrees. Well, what do you think that means about 30 degrees and 210 if both the reference angles are the same? What do you think we're going to see?
The cotangent.
I forgot the line.
They're part of the same line.
They're part of the same family. So what that means is, when we think about sine, cosine, tangent, they're going to be similar except for what?
Different sign.
Different signs.
Oh.
Yeah, that is exactly right.
G and S signs, not like I and ES signs.
Correct. Alright. Now, this one is 45. This one is 30. This one is 45. This one is 60. 60. 45. 30. Okay? Look at these numbers that you see over and over again. What? 30, 60, 45?
36.
Huh? Do you think that has something to do with the special right triangle? That might be where we're headed with this.
No.
Yes, it is. Okay.
Just building.
Yes.
Do we have to draw like this for
Is there a step 2?
That's why you
I would like, if I asked you to do these, yes, I would like to see the swirly. So that I can visualize that you understand what the angle's actually doing. Okay? Alright, so speaking of 30, 60, 90, 45, 45, 90, what if I told you the reference angle is 60 degrees, which is more information than I had to give you. Yeah. And the point it passes through is 2, comma, negative 2, root 3.
And I know it's a 36.
This is really all I had to give you. Okay, which quadrant is this located in?
3.
No. Second.
I feel like we're shouting out numbers. It's in the 4th quadrant. Alright? So it lives over here somewhere.
Oh, okay, negative.
Alright? So, wow, that wasn't a line. Let me try that again. Does it look like it's kind of a 60-degree angle? Yes. Alright, so if this is 2, and this is negative 2 roots of 3,
That's the other one's 4.
could you give all 6 trig ratios?
Yes.
Yes. Certainly we could.
Would we multiply
Okay?
it
So,
by...
I didn't even have to tell you this. Because we should get to the point where we're recognizing our 30, 60, 90s. So if this is 2, this is negative 2 roots of 3, what would the hypotenuse or the radius?
Negative 4.
4. Okay?
Not negative.
So, what would sine of theta be?
Sit over at hypotenuse.
Negative 2 root 3 over 4, which is negative root 3 over 2.
How do we get?
What is the sign of 60 or the sign of
30,
negative?
60, 90.
Oh, geez.
What are they saying?
Cosine of theta would be what? 1/2. Okay, Kyle, you already figured out there's probably a nice little relationship between 30-degree reference angles and 60-degree reference angles. Yeah, there is. All right, tangent of theta would be what?
Negative 2.
Negative square root of 3.
Negative 2 root 3 over 2, which is negative root 3.
And you can do that.
And then what do we do? Reciprocal. So cosecant. And once again, you're allowed to leave radicals in the denominator. Secant. And cotangent.
1 over.
Negative 1 over root 3. Yes.
I understand what sine, cosine, and all their inverses do, but I don't really get why would you need the cosecants and secants?
Because of where we're going with it after this, to solve trig application problems, we don't. And that's why when we learned solving, we didn't do them. But what we're doing next is we're looking at graphing, we're looking at trig identities, we're looking at lots of different unique things that have further application, and we do need them. Yes, John.
Is 60 degrees, is that in the left angle right here?
The 60 degree is the reference angle. Yes, sir.
And you don't even know that's positive or negative.
Okay, huh?
And it doesn't matter if it's like clockwise or counterclockwise for the reference angle.
The reference angle is always going to be positive, but we knew it had to be in the fourth quadrant. If I gave you the angle, guys, what would give me an angle that would have gotten us here?
Negative 60.
Negative 60 or positive
300.
300. Yeah. Okay. All right. So, which of these points, A, B, or C, could lie on the terminal side if our angle of rotation is 135? B. Okay. What is the reference angle? 45. Okay. So, what would sine of theta be?
It would be 1 over square root of 2.
And you want
3 over 3 over the square root of 2.
Yep, 3 over 3 roots of 2.
Yeah.
So it simplifies to 1 over the square root of 2.
Yeah.
Very good. Very good. All right. So,
Okay, that'd be redundant for not doing.
all right. Alex is going to pass out your assignment.
I did.
Oh, wait. There's one more slide. That was a little premature.
That's literally me.
One more slide. I missed the last
I
slide.
made this.
Okay. Which quadrant does cosine of theta equal 2/5 if tangent is greater than 0? Okay? So, where cosine is your x, right?
Right.
So, we know x is positive, so it can either be 1 or 4. 1 or 4, because those are the two quadrants that your x is positive in.
Tan is positive.
But where is tan positive?
1.
1.
3.
So now we know that this must be located here. Okay? So then we can figure out the y, couldn't we? Yes.
Can't tan be positive in quadrant 3?
It can, but cosine can't. Okay? So it must satisfy both. All right? Okay. And then could you find the other 5 ratios? Yes, because we can solve for y. And then we could find all 5.
I get it.
All right? Okay. Where is this one?
4.
Okay. Tangent is positive. 1 and 3. But sine is negative. So it is 3. Okay? So that's how we can determine where things are. So what would y be?
Negative whatever.
Y is 1. What is it? Excuse me, 3. What is x? 1. Okay, but you're right. Because it's in quadrant 3, both of these must be negative. Okay? Now Alex is going to pass out your homework.
Do you need to check my